that I'm not familiar with. So Aziza, I know. Right. Hidayah, Asma, okay. Right. Helmi, Nadia, Cheng Hao, Mengru, Sajida. All right. Deng Hang Yu. Yu Xing. Yeah, okay. So you have finished learning about the basic of probably what is sustainable chemistry. Dr. Ili has discussed about waste management, which is very important. So my part will be a bit on extra chemistry, which is more on solvent, green solvent. So for the first hour, I just would like to introduce, yeah, regarding the green extraction, as well as introduce to this topic before we go deeper into the technique. All right. So if you have questions, feel free to ask me. So, what is your view when you first come across this word, green extraction or green chemistry? Can I have some views for those who are available today? What do you think? Ahmed, are you here or you're back in Malaysia? Ahmed, are you here, Ahmed? I think everybody can hear me, right?
Yes, Prof.
All
Yes,
right.
Doctor.
Yes, okay. So let's say Aziza, when you introduced to the green chemistry, what is your thinking about this? Aziza, are you available to answer?
Mm. Uh, yes, Prof.
Yeah, okay. What is your view?
Green chemistry is anything that can reduce or minimize any pollution, contribute any pollution.
Okay, that's what you have learned with Dr. Ili.
Yes.
Okay. All right. What is your thinking, Sajita?
Um, Process or a procedure that can help us to prevent hazardous waste being generated.
Mm-hmm. Okay. All right. So help me. You're working in pharmaceutical companies, right? I
Yes,
still
Prof.
right. So what is for example, any action by your company in contributing to new green related action to reduce all this waste?
First of all, green extraction, my point of view is perhaps we can use we did the extraction using less toxic solvent.
Yeah.
Okay, so for my company extraction, I'm not sure whether I'm talking about the process.
Mm.
The what we did is we reuse or recycle the acetonitrile
Oh.
instead of it is about more than 1,000 kilo. We reuse the acetonitrile during manufacturing of the insulin.
During
Yeah,
so I just out of curiosity, when you recycle, can
yeah.
can you get 100% back or
Um,
any reduce in performance or there is significant?
yes, we have a few limit to monitor. For example, the percentage of the acetonitrile.
Mm,
Then what is the zinc content or heavy metals content inside the acetonitrile?
mm,
Because we did this during the buffer for the yeast. So all this will include in during manufacturing. So we need to monitor all these trace elements so that we can reuse. If it is over the specific limit, then we will discard that.
Okay.
It is we can reduce the cost about million for this.
Yeah.
Yeah.
All right. So I think it's good to hear that at least the company is doing something. Probably, yeah, in terms of recycling, usage of solvent. But of course, we need to move further ahead, which is thinking about alternative of the solvent. At this moment, of course, there's a lot of hurdles, especially in terms of cost, in terms of a new technique. Whenever that we have a new technique to be proposed or to be changed in the setup, it will, of course, um, we need to retrain, we need to invest in the infrastructure. So we understand the issues, but something has to be done to move towards greener protocols, greener technologies, okay, thinking about the environment, thinking about the earth that we need to save. So we need to think about this. So separation technique is something that you have learned in the subject, in the separation technique, and which is related to extraction today. So I hope that you still remember your prior knowledge, which of course I will not uh, repeat again during your solvent extraction, liquid, which is a liquid extraction. So the calculation involved, which is something that we don't do here, the distribution ratio, the distribution coefficient, the process itself, the organic phase, the aqueous phase, okay, and then the efficiency of the extraction. And also in the separation technique subject, you also have learned about solid phase extraction and micro extraction. So solid phase extraction can also be green extraction, provided that we avoid toxic solvent, and then we try to minimize the use of solvent. So with the use of solid phase extraction, sometimes we use resin. You already learned in separation technique. Those resin usually is regenerable, meaning that you can use back. You can clean it up and then use the solid resin uh, for next use. And I think you also learn about micro extraction. So micro extraction involve a very minimum solvent. Okay, sometimes micro extraction involve liquid as well, but very minimum solvent. And I assume that you have learned all this in separation technique subject, which is a compulsory subject for all of you. Okay, so this one should be something that you have learned, which is prior knowledge. So green extraction, the word extraction is something, it's not something new for you. Uh, it's a collection of extraction methods that prioritize environmental sustainability. So the word is sustainable. Uh, just like what you have said, some of you have said about reducing solvent and not just about solvent, also energy consumption and reducing waste. Okay, so we have not discussed about energy consumption, but uh, yeah, this is also considered under green extraction. Okay, and the target is also related to energy. So why is it important? Definitely, we know this is important because it will try at least contribute to reduce the the effect towards ecosystem, and solvent is not good. Most of it are hazardous. Okay, So I hope that you read the journals that I have provided, two journals. One is on hexane, which is widely used in our industry, especially food related industry, because hexane is considered edible food. So not edible, uh, what do you call? Considered safe, but it's not actually safe. Uh, if you read the journal, then you understand that it has some toxicity towards human health. So reduce cost and improve efficiency. Of course, this is something that we want to achieve, especially in energy consumption. So when we say about green extraction, uh, the principle is, as Helmi said, it's about the we can regenerate, but sometimes we also have to look at the toxicity of the solvent being used. Okay, so these are the things that considered as a principle of green extraction: renewable and biodegradable solvent. Okay, so ethanol is considered renewable because we can obtain ethanol from bio-based ethanol. So it is considered something that we can reproduce and is biodegradable. And the use of CO2. So uh, when we hear the word of CO2, it's always like negative stigma. Okay, it is related to uh, climate change, is related to this ozone layer. So, but then there is some usage of CO2. So one of the most important research now is what we call as CO2 capture, okay, or carbon capture. So from the process of burning or any other process that producing CO2, we need to we can have or we can couple it with CO2 capture. So the purpose of having CO2 capture, we can use back the CO2 instead released to the environment. So energy reduction through efficient techniques. Okay, so certain techniques. I don't have any personal experience using uh, other than normal techniques like liquid extraction, solid phase extraction. That's quite normal to me. But the usage of supercritical fluid, subcritical water, I don't have any experience, but it's supposed to speed up the process of extraction. In that way, uh, energy reduction can be obtained. Yeah, to meaning that the time taken to extract is reduced. That's how the energy is being reduced. Waste minimization and recycling of solvents. So just like what Helmi said, recycling of solvents, as long as the solvent is not toxic. So it is considered under principle of green extraction. And regeneration of the resin also considered waste minimization. So every time we use solid phase extraction, and then if we can regenerate the resin being used, that is something very important. Okay, so if you know about uh, the uh, the oil and gas industry, especially in Southeast Asia, they have the issues. We have the issue of mercury contamination and other metals as well. And they are not just metal. There's a lot of other contaminants that we have to take care of before it can be commercialized. So the issue is most of it are using activated carbon. And activated carbon, they just capture all these contaminants. And then we have the issue of secondary disposal. We clean up the oil and gas waste, But what happened to the activated carbon that is being used to capture all these contaminants? So we have an issue called secondary disposal. How do we dispose? So at this moment, regenerating the activated carbon is not economical. So it's more like single usage. Okay, you use it and you need to dump it. You need to um, dispose it. So it triggers the issue of secondary disposal, which is not considered green. So the fourth one, application of safer non-toxic methods, of course, uh, that is under consideration of green extraction. Okay, so this is the normal one, conventional, which we, especially in chemistry, most of the time we use this. Chocolate maceration, hydrodistillation. It took hours, uh, sometimes many hours to have uh, the extractant coming out from this grid, for example. You want to extract active compound, so it's actually it's not just the hours and the solvent being used. Yeah. So when you need long hours, that triggers high energy, which is not economical. Okay. And solvent consumption is very high with this conventional extraction, right? And the other thing is, once we extract out the component that we wish to have, um, the existence of the solvents that's supposed to be out from the extract is not 100%. Okay. The solvent, it is still there in the extract. Okay. The extract means that the component that we wish to have, the active component that we wish to have. So instead of it's supposed to be solvent free once the extraction is over, but it is not the case. Some percentage of solvent still in the extract, which is hazardous to us. Uh, yeah, I just want to check whether when we talk about extraction, yeah, probably Helmi understood the extraction process. But what about the rest of you? What is the purpose of extraction anyway? Athma, can you hear me, Athma? Athma, hi. Hello? Ah, okay. Okay, Yuxing, Yuxing. Can you hear me, Yuxing? Okay, can you answer? What is actually the purpose of extraction? Just checking your understanding. Oh, you're meeting in the library. You are in the library. Okay. Okay, anyone can answer. What is actually the purpose of extraction? This goes back to the separation technique. Anyone?
So, Doctor, can you hear me now?
Yeah, yes. Now I can hear you.
I have problem. Sorry about that. You wanna about the extraction?
Yep.
What, what I know about extraction is when
Mm.
we need to separate,
Okay, separation. All right, good.
make separation or to for material for that mixed with, or it's not mixed. It's originally from a raw another material like that. I don't know how to explain it, but like taking oil from a plant or something like that.
Okay. Yes, yeah. So one thing is separation, and what Ahmad is trying to tell us, for example, essential oil, okay, which is very important. There's a lot of usage of essential oil from plants, from any other resources, okay, and active compounds for drug development. Okay, so Helmi just now talking about the production of insulin. Okay, I don't know what raw material that they use. I suppose it is from microbes. So extraction of those important biocomponents like essential oil or active compound for drug development. Apart from that, extraction also can help us with analytical analysis, chemical analysis, which is pre-concentrate. Yeah, if you want to do analysis in the lab, sometimes the sample that you have a very low concentration of the analyte that you wish to analyze. Okay, I hope that you remember the word analyte and you want to do analysis. So the purpose of solvent extraction or any other extraction is to pre-concentrate, to increase the concentration of the analyte so that we can have a better analysis. Because if we do analysis at very low concentration and the instruments or the technique that we use is not sensitive, then your analysis will not be accurate. Okay, so those are among the objective of extraction. So regardless of the objective of your extraction, whether it's separation, isolation, or pre-concentration, so we need to make sure or try our best to use a greener technique. Okay, so why do we move to this greener extraction? For example, we have supercritical fluid, subcritical fluid, ultrasound, microwave, pressurized liquid, pulse electric field. Okay, because it speed up the process. Okay, it speed up the process. This one is more on still on like boil heat base. Okay, so this one speed up the process. And when we speed up the process, one thing we use lower energy. That also contribute to sustainability. When we also can obtain the output or the extractant faster, then we can reduce the usage of solvent. So very efficient. Not to that one. I I keep my view on that because most of the extraction new extraction technique they are sometimes at research stage, development stage. So the comment about very efficient and highly specific is very not to say accurate for all. Okay, so I reserve this. Um, just now, presence of solvent in extract. Yeah, for example, okay, I'm just saying because Helmi talk about acetonitrile. Okay, so if we have uh, traces of acetonitrile in the extractant, which is not supposed to be, okay, that is something that we need to be worried about. So for grain extraction, supposed to be very low trace of solvent should be there, okay, which is good, okay. But this one also, just like the very efficient comment, that depends on the process that we are talking about. Not all, okay. Solver recovery and reuse is more, okay, depends also on the technique. But definitely we have to invest because the setup now is different compared to the original simple setup, okay. So higher initial cost. We need to set up a new infrastructure, and then whether the green extraction method can scale up the same as the conventional extraction method. So these are something that we have to think about, right? So it's not always nice and everything goes as well. Okay, so in traditional extraction, yeah, the solvent is usually organic. Not all is toxic, but usually we try our best to avoid organic solvent because there are certain toxicity. When we talk about organic solvent, there are certain toxicity. And for green extraction, uh, okay, because solvent is the most important thing in extraction. So try our best to use this kind of less toxic, for example, ethanol, water, and there are other solvents that we are going to discuss later. Energy use, traditional extraction because of the usage of heat and all that, long time of the extraction, so the energy is high. And by green extraction, we use advanced techniques that speed up the process, so at least the energy can be reduced. And waste, okay, minimal and recyclable. So this is the design that we need to do to minimize the waste. And sustainability is about how eco-friendly and towards environment. Okay, so these are green extraction, considered green extraction. We will discuss this in the later hour or probably in the later um, lecture. We have 3 lectures of green extraction. So depends on what we can cover. Okay, we have supercritical fluid extraction involve CO2. Okay, and then we also have what we call as subcritical water, which I don't put it here. Okay, we can discuss it. Microwave assisted extraction. This is for, it can be small scale, it can big scale, depends on uh, what setup that we can do in the lab or industrial scale. And ultrasound and pressurized liquid extraction. And at last but not least is enzymatic extraction. Okay, Helmi, are you available?
Yes, doctor.
All right. So in your insulin production, what kind of extraction method that you're using?
This one I'm not sure.
But you know the solvent, which is
Yes, yes.
okay. All right. Okay. So these are the common grain extraction. Okay. And for example, because we introduce microwave, so the process is shorter. We introduce ultrasound, so that also shorten the process of the extraction process. Okay. So as I said, this one is just an introduction. I will go deeper on the setup of the supercritical fluid extraction. We have it in UPM. I think they still have it. We have a center supercritical fluid extraction in food faculty, and they use it for extraction of essential oil, for example, from black pepper, from other herbs. But the thing that I heard is um, it is a bit expensive. So I don't know why it is expensive. Probably the maintenance of the whole setup is high. Probably, I don't know. But it is, of course, green because you're not producing solvents, waste in terms of solvent, because CO2 is used as a solvent, and I believe it is recyclable, okay, non-toxic, recyclable, highly selective, and they use it for special extraction, like as I mentioned, essential oil, removal of caffeine from coffee, because some people are, cannot stand caffeine, cannot have caffeine. So herbal extracts, there's a lot of herbal extracts used in cosmetics, in shampoos, in soaps, special for certain people. Sometimes they have conditions like you need to have herbal extracts or pharmaceuticals or drugs. Yeah. All right. Development. So even though I think the maintenance is quite high, but it is in fact green, yeah, because of the recyclable of the CO2, and then it does not have waste. Yeah, right. So this is generally the setup. Okay, you have CO2, right? I'm not sure where they put it here, organic solvent, but it's the CO2 who did the job of the taking out the bioactive compound. But still, you can see that the bioactive compound will be transferred into organic solvent as well. Because, uh, for example, essential oil, you cannot put it in aqueous. It's still in a, you need to keep the bioactive compound in a uh, suitable solvent. So in green chemistry or sustainable chemistry, one of the key point is we're talking about green solvent, okay, to replace organic solvent. So we will discuss that in further part. Okay, so this one is just to introduce you, but we will discuss a little bit more on the supercritical fluid. Yeah. All right. Next one. This one is quite simple to understand. Is microwave assisted extraction. So the principle is similar to the microwave that we have, okay, in kitchen. But of course, for industrial scale, for microwave assisted, the power, the energy is different. But the principle is similar. Okay, the molecules will be certain vibration, and this trigger the uh, movement of the molecules. And by this, it will help the extraction of the components, the biocomponents, or whatever compound that we wish to uh, extract can be extract out easily and in less time. Okay, so I mean similar. If you put your food, especially if you put like oily food in microwave, you wish to heat it up. If you put it there, you can after the microwave process, you can see that the oil is actually outside, um, outside from the food already, which yeah, sometimes which I don't like. If you microwave some oily food, then the oil will be extracted out. So the same process actually, it's just that it helps to enhance the process. So the faster, so when you have faster results, you use less solvent, and um, uh, the process will be requires low energy. So same uh, function, extraction of bio compound, essential oils, okay, has been used for microwave assisted extraction. So it can have larger setup, okay. For example, you can see that this is example of plant material with solvent. We still use solvent, but now it is assisted with, yeah, assisted with. That's why it is called microwave assisted with microwave process. So instead of just chocolate just now, with no external forces, we have now external forces to help extract the component out from the uh, plant material, for example. Okay, so actually, if you look at the microwave, we can have larger setup, industrial setup. So the size depends on your application. This one also quite similar to microwave. So instead of using microwave, uh, the usage of ultrasound, okay, sonicator, like sonicator in the lab. So by supplying ultrasound wave to assist the extraction. So this is the ultrasound generator, okay, sonicator, and this is the extraction setup. So we can increase the extraction process, and so that we can reduce the time as well as we can have more yield coming out uh, from the sample, from the plant sample of or any other that used to do extraction. Okay, so similar to microwave, but this time around is ultrasound. The wave is different. Okay. um, there are others, for example, that I didn't discuss yet, yeah, which is the pressurized liquid extraction, enzymatic reaction. So this one we will discuss all this. We'll look at the setup in detail later. If it is not today, then the second lecture next week. So application of green extraction, I think, is similar to what application of conventional extraction. Okay, most of it is to extract important compound, for example, antioxidants. Okay, you consume vitamins, you consume active compound from turmerics, a lot of, like, for example, now they're talking about tocotrienol from oil. We have it in palm oil. Some took it from olive oil, tocotrienol. Okay, so we don't consume oil, but we consume the tocotrienol compound from the oil. So in order to have that, we need to extract the tocotrienol from the oil. Okay, so that's one of the definitely important extraction application extraction. Recovery of bioactive compound for pharmaceutical. That one is something very commonly used. Natural dyes, okay, dyes from plants, from fruits, pigment for textile, but I think this one must be very expensive because usually natural dyes and pigments extracted is for food, not for textile. For textile, you're still using the synthetic chemicals, okay? Flavoring agents and food and beverages, okay? So extraction of this biochemical compound from plants, from fruits, are very important applications of green extraction, of even conventional extraction. Okay, so what are we talking about when we talk about green extraction? The issues are scalability. Okay, as I mentioned just now, many techniques are still at development stage, especially the green solvent. Initial investment can be very high. You can think, because I know that most of you, 50% of you are working out there. So when you need to change the setup, when you need to change all this infrastructure, that will incur a high cost. You need to find a new expertise and you need to change the facilities. So that is something, very costly. And it's about regulation as well. So all this while we are using, for example, like Helmi said, acetonitrile. So it comes with certain regulation, certain standardization. So if you are to change to green solvent, then we need to think about a new protocol, a new standardization. So just now we talk about checking the metal contents. So if we are to use a new solvent, we need to have a new system to check. Okay, So future trends, okay. So this is something, of course, people are talking about AI, automation, nanotechnology. So this also can be integrated with the green extraction technique. Sorry. So some important part, okay, actually for me is the most important part in the green extraction technique. What we discussed just now, like supercritical fluid, subcritical water, which I don't mention, microwave assisted, ultrasound assisted. There are two others that I didn't go a bit detail, which is enzymatic and I don't remember PLE just now. It is still using organic solvent. It's just that due to the time reduction of time, so we reduce the energy consumption and probability the usage of solvent also being reduced. But what about if we can replace the organic solvent with alternative solvent? In this case, we are talking about green solvent. Okay, so this is more chemistry. So this is the common solvent. Sorry. Being used in the industry. You can see, okay, if it is water, then it's okay. It's considered green. Methylene chloride. Yeah. And then acetone, ether, at this stage, it is still considered uh, green. Okay, so the use of water. But when we start talking about hexane, then even though it's commonly and widely used, especially in this extraction of oil, because hexane is very functional, it's very useful in extraction of oil. But if you read the journal that I provided you, then you can see that it is uh, toxic to human being. Okay, so please do read, then you understand that of my concern at this moment. So this is common solvent being used in the industry, but there are alternative solvent. We can talk about, yeah, just now we have talked about CO2 as the solvent. I also mentioned about ethanol, because ethanol can be obtained from resources, biological resources or plant resources. So it is considered renewable and can be considered green. Okay. You can see that ether, it is still considered under green solvent. Water, ethyl acetate, ether ester, and there are a few that I would like to introduce to you, which is ionic liquids and deep eutectic solvents, DES in short. So the rest are, for example, of interesting as well is limonene. Yeah. So these are all considered alternative green solvent instead of using hexane, which is widely used in food industry. So what are the characteristics of green solvent? Okay, so it's supposed to have low toxicity, definitely. Biodegradability, I hope you understand what does it mean. Meaning that it can be degraded if we put it out there in the soil, it will degrade by the microbes, so that is biodegradability. Low VOC, okay, so less VOC released to the environment. Renewable sources, like just now, is bioethanol. High solubility power, definitely, because as a solvent, it has to solubilize. So in terms of selectivity, is important because in extraction technique, That is our ultimate aim, to selectively dissolve the component or the biocomponents that we wish to extract. Okay, and not flammable. Okay, compatibilities is same with selectivity. Not selectivity. Compatibility means that the extraction, if you talk about solvent miscibility, yeah. So that one, if you understand from separation technique, in order to do liquid extraction, the aqueous phase and the organic phase must not be miscible. Okay, so compatibility of solvent is very important, and reduce carbon footprint. Definitely one of our aim. Yeah. So this is again examples of commonly used uh, green solvent, but in different view. So subcritical water. Okay, I'm not going to talk about this again. So the first one, okay, before we take a break, I want to introduce about ionic liquid. Okay, so what is ionic liquid? Anyone know? Anyone have heard of ionic liquid? Wang Hongyan, are you available? Or are you in the library? Hongyan?
Sorry, doctor.
Yeah, so what, have you heard about ionic liquid?
Yes, for some liquid.
So what do you know about ionic liquid?
Mm,
Anyone? Okay. So ionic liquid is made of actually cations and anions. Okay. So it's a liquid, yes, but you can see that the difference when we talk about cations, we are talking about, for example, calcium 2 plus, zinc 2 plus, magnesium 2 plus, sodium plus. Okay, those are cations, right? And when we talk about anions, we know about chloride, nitrates. Okay, those are simple anions. But in ionic liquid, it's a combination of cations and anions, but they are alkyl, or probably what we call as complex cations. Yeah. So you can see here it is cations because of the positive charge, but you can see that it is not a simple cations like magnesium 2 plus or copper 2 plus. So is alkyl. So the names are various third butyl cations. Okay, but it is not a simple cations. Yeah. So and it is combined just like acid-base reaction. Okay, you have a reaction between cations and also complex anions. Okay, so that's how ionic liquid is formed. Yeah. So why do we need this? Okay. So if you look at here, okay, these are among example of um the usage of ionic liquid. So I think I don't have it here. Okay. So this example of ionic liquid, butyl 3-ethyl imidazole BMIM, in short, BMIM. So you can see this is one example of ionic liquid, and this is the cation, okay, the complex cation, and this is the anion. Okay, so ionic liquids are salts, okay, that exist in a liquid state at or below 100 degree, often below room temperature, because if you heat it up, they are degraded. So we need to careful about the temperature. Okay, so they are composed of large organic cations, that just now butyl 3-ethyl imidazolium. Okay, so that's the cations, and inorganic anions, tetrafluoroborate, for example. Okay, so this is example of cations being used and anions being used to form ionic liquid. So they are salt. They are composed of, okay, these liquids offer unique properties like low vapor pressure, of course, because they are not volatile. So they don't have VOC, volatile organic carbon, high thermal stability, and tunable properties, making them useful in various applications. So when we say about tunable properties, we can change the types of cations, we can change type of anions to suit the process that we wish to do. For example, okay, do I have example? I don't have. I will explain to you one example on how ionic liquid can dissolve cellulose. Okay, so this is cellulose, right? Cellulose is difficult to dissolve. Yeah, because cellulose is like woods. Okay, it's very difficult to dissolve, and it requires a lot of solvent. Okay, hazardous solvent just to dissolve woods. Okay, so why do we need to dissolve cellulose? There's a lot of application to that, but ionic liquid has, specific types of ionic liquid has managed to do this. Yeah, to dissolve the cellulose. So a few key points, key characteristic and properties is low melting point, meaning that it becomes liquid. I talk about it cannot withstand high. It's supposed to be high thermal stability. They can withstand high temperatures without decomposing, okay, and low vapor pressure. So this is one of the important um, and a lot of research has been done in formation of ionic liquid, and they have many applications. Among them, it also being used in batteries, in fuel cell, okay, in supercap as solid electrolyte, okay, and it also being used to dissolve cellulose, which is very important function. So, right, so solvent. So it has been used as to replace organic solvent, electrolytes, catalysis, and used for synthesis of materials. Yeah. So in biotech also, ionic liquid can be used in processing and extraction of biomolecules. Right. So I think we stop here, and I hope that during the rest time, which is 7 to 8, please read through the journals that I have provided. So they talk about ionic liquid as well in one of the journal, I think. So understand the process. Okay, whenever we talk about extraction, okay, the process is about solvation, how the solvent dissolve. Okay, so if we understand water, this is how water dissolve. Okay, it's about polarity, and you know this is H2O. Okay, so the oxygen with negative charge, not partially negative charge, and the hydrogen, which is partially negative charge. This is due to the electronegativity difference between oxygen and hydrogen. And when we dissolve salt in water, so this is what we get, okay? The sodium plus being solvated this way. And we have also chloride being solvated by the H2O. So the same process, instead of H2O, what happens if we use ionic liquid? So how does ionic liquid solvate the compound? Okay, so how the process of solubility, how it solutes, how it dissolves the solutes. Okay, so the chemistry of ionic solvent. All right, so we stop here. So I'll see you back at 8 o'clock. Okay, all right,
Okay.
everybody? Okay.
Okay, Prof.
Okay, we have discussed about on the surface some techniques for green extraction. And in those techniques, one of the most important part, even though it is for microwave assisted extraction, ultrasound assisted extraction, uh, solid phase extraction might be, they still sometimes use solvents. Okay, so at this moment, still the practice are using organic solvents. So how do we replace this? Do we have alternative to organic solvents, which is known to be have some toxicity? Okay, but of course there are some like ethanol, ether, ester, which is considered non-toxic. But what if we have alternative? Okay, so this is some of the alternative in solvent development, and they have some specialties compared to the existing organic solvent. Okay, so for example, the first that we are going to discuss here is ionic liquid. Okay, so maybe some of you have heard about ionic liquid. So ionic liquid is a combination of cations, complex cation, bulky cations. You can see they are not simple cations like sodium plus, calcium plus, 2 plus, okay? And also it combined with complex anions. Yeah, it's not as simple like chloride, fluoride, but they are complex anions. So this combination of bulky cations and ions is how ionic liquid is formed. So this is an example of ionic liquid. So you can see is butyl 3-ethylimidazolam as the cation combined with tetrafluoroborate, which is the anion. So in short, it is named as BMIM, BF4. So what's so special about ionic liquids? Yeah, ionic liquids are salts. So most of the time when we hear salts, we know that it's going to be solid most of the time. Okay, but special about ionic liquids, okay, they are liquids. Even though they are salt, they are in liquid state, even below 100 degree. Okay, so just now I mentioned about it is not stable. It is stable. Okay, it is stable in a liquid form, even above 100 degree. It is not easily degraded. Okay, so if it is water, water is one of a green solvent. You can imagine if it is above 100 degree, then it becomes vapor, right? So for ionic liquid, okay, special because it can retain as liquid below 100 degree and above. They are composed of large organic cations, as I mentioned before, and inorganic anions. So these liquids have unique properties, okay? Better to have it here. Low melting point, meaning that it can be a liquid. Just a moment, yeah. sorry. Um, so ionic liquids are defined by their low melting points, meaning that it can it be in a form of liquids, salt in a form of liquid, even below 100 degrees. Okay, making them liquid at ambient conditions, which is very important features when we need to use it as solvent. Okay, high thermal stability, so they can withstand high temperatures without decompose, not degraded, which is significant advantage in many applications. And we don't want VOC, so low vapor pressure. Okay, means they are not volatile, and of course, if it is not having high volatility, then it is much more preferred compared to the traditional organic solvent, which is known as highly volatile, produce a lot of VOCs, with all the smells we don't want. Okay, so that's the beauty thing about ionic liquid. So what are other important characteristic of ionic liquids? Tunable properties. So why it is tunable properties? Okay, as we can see from the beginning, we can combine many combinations of cations and anions that suits our application. Okay, so it's like you have different clothes every day. You can combine different handbags, shoes, okay, suitable for your if you have different events. Okay, so if you have different applications, you can combine. Let's move to you can combine different cations and different anions. So ionic liquids can be tailored for specific applications. But of course involve synthesis and then understanding the properties of both cation and ion. So non-flammability, okay. So whenever we work with organic solvent, one thing that we are afraid of is about flammability. Okay, they are highly flammable, most of them, okay, and afraid of fire. Okay, so organic solvents, has that characteristic of flammable. But many ionic liquids are non-flammable, so it actually has this advantage. And the other advantage, because ionic liquid can also be used as electrolytes in energy storage, in solar cell applications. So their high ionic conductivity, because they are made of cation and anion, make them useful in electrochemical applications like electrolytes in batteries, okay, for energy storage, for fuel cell, and for solar cell, okay. So applications of ionic liquids, like what the characteristics are, the most important in extraction is, of course, its characteristic as solvent. Okay, as I mentioned, even though we can do like microwave extraction, microwave assisted extraction, ultrasound assisted extraction, but still we are still using organic solvent. So if we can replace the organic solvent, it is much better. So electrolytes, okay, is in other application, not green extraction. Okay, battery energies for energy storage and other energy technology. Ionic liquid also can be used as a catalyst for certain synthesis. Yeah, so these are also, but the most important part that we are interested in for this particular subject is the solvent characteristic of ionic liquid. So these are also some applications of ionic liquid. Yeah. All right. Before we understand solvent, okay, we need to understand the solvation process. how solvent dissolve. Okay, so the basic one is water. So solvation process of water, since water is highly polar, okay, it has semi-negative and semi-positive, okay, due to the difference of electronegativity between oxygen and hydrogen. So they are um, a bit a positive charge and a bit negative charge. So they can solve it, salt, yeah. And if in this case, for example, sodium plus and chloride, so we can see that this is the solvation process by water. But how does solvation process in ionic liquid? So in ionic liquid, like I have discussed, it contains cation and it also contains anion. Okay, so these two features, okay, depends on what compound that we wish to solve it. Okay, it will behave like just like water just now. It is based on charges. Okay, so what is the charge of the compound, for example, and what is the characteristic of our interest, the compound of interest that we want to solve it to dissolve, and this cation and anion will rearrange itself so that the solvation can happen. Okay, so I hope you understand the word solvation, because that is the mechanism of how solvent dissolve. Yeah. So solvation ability of ionic liquid, okay, what is it? Is the ability of ionic liquid to dissolve or surround the molecules. Same how water dissolves salt. Okay, so I have shown you the pictures. So ionic liquid are unique because their structure can be tailored. So based on that, we know ionic liquid has cation and has an ion. So it can rearrange itself depending on what kind characteristic of the compound of interest that we wish to extract. If it is polar, if it is non-polar, the ionic liquids can be rearranged for the solvation process because it contains both. It contains ionic compounds, okay? And the other one, if you see, it also have organic alkyl group, okay? So if you look at the cation, why is it not, why it is not a simple cation? It has alkyl group. Alkyl means carbon, hydrogen, yeah? So if it is polar, then if it is polar compound that we wish to extract, then the properties of these charges, okay, is useful. But if it is non-polar compound, then the alkyl group now comes into action. Okay, so we can see that ionic liquid can dissolve polar and also can dissolve non-polar. Okay, because it has the functional groups of both charges and alkyl group. So that's why ionic liquid is special. So how does it solve it both? Okay, ionic liquids can solve it what range of substance due to the versatile chemical structure. The solvation capability is influenced by the specific cation and anion. So meaning that we need to know the properties of the specific cation and anion before we can design what kind of ionic liquid suitable for our application. So since ionic liquid have those two features, the ionic and also the alkyl group, so the ionic nature with their charged cations and ion plays a crucial role in solvation of polar molecules. Yeah. So they can form ionic interactions and can influence the solvation. Okay. So just like the pictures just now, the charges will solve it, the compound of interest. But what is the function of the alkyl groups? So the organic alkyl group, just now the R stands for the carbon, hydrogen, okay? That is alkyl groups. Present in ionic liquid, it provides non-polar environment, okay? So as we know, in order to dissolve non-polar, we requires non-polar solvent. Before this, that's what we know. And in order to dissolve polar solvent, we need polar, in order to dissolve polar compound, we need polar solvent. But since ionic liquid have both, they are able to be designed to specific solvation of the compound. This alkyl group can also interact with polar substance, further expanding this. So I don't know how these alkyl groups interact with polar substance, but then this definitely help to provide a non-polar environment. Okay, so let's look at okay, this one. So this is one of the most important applications of ionic liquids, because as you know, when we want to extract from plants, from bugs, from tree, the most important is to break down the cellulose. Okay, this is the most difficult to break down. Okay, usually we need to use a lot of solvent if it is organic solvents, and time consuming. So by using ionic liquids, you can see that this is the chemistry involved. Cellulose also contain this is hydrogen bond. You can see the interaction between positive, partially positive charge of hydrogen and partially negative charge of oxygen. So the hydrogen bond in the cellulose can be affected, or can be what is the word? Okay, you can see that it is affected by the charge of ionic liquids. Okay, so the positive charge can interact with the oxygen, which is partially negative, and the negative charge from ionic liquids can interact with the partially positive charge from hydrogen. So they sort of break down the hydrogen bond in the cellulose, okay, which is among the important process to dissolve cellulose. Once we dissolve the cellulose, then we can start to extract the compound of interest inside the plants or any other cellulosic material. Okay, so examples of solvation. So if we are interested of proteins, it can solvate proteins. So as we know, proteins contain negative charge in the nitrogen, okay, amide, okay, they have nitrogen protein. So we can use ionic liquid, since ionic liquid are also charges, charged compound, a charged solvent. So influencing their folding and stability. Some ionic liquids are used as solvent for CO2 capture. So remember just now I mentioned about CO2 capture, which is very important research and very important trends nowadays, because we want to capture CO2. We don't want to release the CO2 into the environment, ending up giving us the greenhouse effect. Yeah, the greenhouse effect. So ionic liquid can solvate lignin. So for biomass, to break down biomass, yeah, because some biomass can be feed as a feeder for biofuel production. So and other than that, of course, in battery as the solid electrolyte. Okay, so a lot of application, but we are interested in this. Okay, the first three, right? All right, so I have shown you this, how ionic liquids interfere with the hydrogen bond in the cellulose, and that's how it breaks down the cellulose. So how do we tune How do we tune the ionic liquids? Is by doing a different combination of cation and ion. So you have to study. We need to know the characteristic of cation and we need to know the characteristic of the anion before we can just combine for the specific applications. So the interaction between the solutes, okay, solute just now, for example, is the cellulose and the ionic liquid. It might be hydrogen bond or van der Waals. Van der Waals hydrogen bond, van der Waals is in non-polar molecule. Okay, determine the extent of solvation. So temperature can affect it. Okay, definitely temperature can affect the process of solvation. Yeah, that one is okay. So I hope you have some ideas on ionic liquids. So if you want to know further on ionic liquids, there's a lot of research that has been done. Okay. For one thing, I know that Petronas has spent a lot of money on this ionic liquid research, and they have patent bought for this ionic liquid formulation. All right. Okay. So we move on to another solvent called deep eutectic solvent. Okay. So again, it is a solvent, alternative solvent to organic solvent. So what is deep eutectic solvent? It has what it is called hydrogen bond donor, okay, and hydrogen bond acceptor. So that is the main components of deep eutectic solvent. The mechanism seems to be quite similar to ionic liquids, okay? But hydrogen bond donor, I think, is positive charge, and hydrogen bond acceptor is negative charge, okay? So it's an interaction, the same interaction, which is electrostatic interaction, just like cation and anion in ionic liquid. So you can see it is also being used for dissolution of lignin, cellulose, but in most DES, yeah, in short, components are hydrogen, HBD, hydrogen bond donors, and HBA, hydrogen bond acceptors. Okay, HBD and HBA. Okay, these mixtures exhibit significant lower melting points than they are in, okay, creating, all right. So let's look at example. Okay, this is characteristic first. If you look at it, just like ionic liquid just now, low melting point. Okay. Okay, but the most important part in DES, deep eutectic solvent, is the hydrogen bond. Okay, the hydrogen bond. And it also has tunable properties because you can mix and match. Just like ionic liquids, you can make cations, you can mix different anions. So like deep eutectic solvent, DES, you can choose the hydrogen bond, HBD and the HBA, hydrogen bond donor and hydrogen bond acceptor, and design it to your specific application. So it is considered green, yeah, compared to the organic traditional solvent because of the biodegradability. Okay, following the principle of green solvent just now, low toxicity and low VOC. Okay, so it falls under, okay, under the characteristic of green solvent. DES can be used to extract and separate various compounds. Okay, so the applications are very wide, including pharmaceuticals, natural product, and polymers. Okay, so this one also, DES also can be used as solid electrolytes in energy storage, okay, fuel cell. And you can see that the advantages over similar to liquids is not flammable, has low vapor pressure, tunable properties, and potential for sustainability. So in order for you to understand much better, to look at the similarities and differences between DES and liquids, you can read these journals reviewing on this matter. Okay, they have some similarity because they are based on charges, but DES is more on hydrogen bond. So the business, yeah, the business, the market on green solvent is getting higher. So you can see this is the report on the marketing side. It is increasing, right? So the green biosolvent, so the production of biosolvent or green solvent are getting noticed by the industry players. So apart from ionic liquids and DES just now, okay, of course there are some downside. The negative side is mostly the high cost, because if it is organic solvent that is currently being used, hexane and any other, they are cheaper. They come in bulk. You don't have to synthesize. They're already commercially available. But compared to ionic liquids and DES, we have to synthesize. It's not commonly commercially available. So that is the downside. And still, it is not yet widely used, only for specific purposes. But since it is green, so I think steps has to be taken to move towards that instead of using hexane. Okay, so there are other biosolvent, green solvent, which is among the organic also, but considered green, yeah? Ethanol, acetone, glycerol. Okay, so ethanol from bioresources. Okay, they are also considered green solvents. Yeah, and it is commonly now being used in these industries. Okay, uh, so one of the, yeah, as we have repeatedly talking about the biosolvent, the green solvent, it has to be biodegradable, non-toxic, low VOC, and mostly if you can do renewable, yeah, we can produce it, reproduce it. Okay, another biosolvent that I would like to talk about before we end is limonene. Yeah, so this is actually started being used in industry. But of course, there's a lot of problem because it's still quite new. So as you can see, limonene is from citrus fruits, okay? From the peel of the citrus fruit, okay? So limonene, a natural terpene derived from citrus peel, is gaining recognition as a green and sustainable solvent. So this is just an example. There are other uh, biosolvents that is similar to this kind of limonene. Yeah, they are so it is a promising alternative traditional solvents like benzene, hexane, toluene, which usually sourced out from petroleum. So that is one thing that we would like to replace. So limonene is one of the solvent, biosolvent. So this is one example. So we know that the issue of solar panels, yeah, solar panels, it has certain life. So after 10 years, the efficiency of the solar panels, particularly this is silicon, yeah, is silicon. I'm not polysilicon. I'm not in solar. Okay, so this polysilicon, okay, they have this certain life time, and the efficiency is around 10 years. Okay, so once it is not efficient anymore, so where do we put this? So we have to think about disposal of this polysilicon. Yeah, we have to think about disposal. So there is one research that they have done, probably a small scale. They use limonene to break down, to break down this silicon. So this is example. I haven't read this in detail. How limonene used to treat solar panels. So the issue of disposing solar panels, the I mean already expired one, okay, is a big issue because it's big and bulky. So where do you store this? The efficiency is no longer there. So how do you how do you dispose this big one? Okay. So this is one of the research to resolve this using limonene. Okay. All right. So why limonene again considered a green solvent? Because it falls under all these characteristic, just like we have discussed many times before, the renewable, biodegradable, low toxicity, and also, I'm not so sure about economic and efficient. I'm not so sure, right? Oh, okay. We have water. Okay, right. So for water, I think, of course, water is the best green solvent, but it has problem in dissolving non-polar compound. Okay, so that's the limitation of water. But in order to have water as the green solvent for non-polar compound, it has to be combined with like subcritical water. Where is it? Subcritical water extraction or pressurized hot water extraction, meaning that we have to play around with temperature. Okay, so water is indeed the best green solvent, but it has problem in dissolving non-polar, okay, molecules, non-polar compound. So in order to extract the non-polar, we have to use this technique, subcritical water and pressurized hot water extraction. So, okay, so these are all solubility reactions. So this is another interesting reading material, especially in food, yeah, because of course food is something that we need to be careful because we consume them. So the green extraction, a novel eco-friendly technique to extract natural products of superior quality. So it is very important for us to think about the right now what is the practice that is being used to extract all these natural products. So is it safe for us? Okay, so it's interesting to read all this. Yeah. So I think that's all. All right. Yeah, it's only 8:30. But so next week, we are going to stop share. Okay, alamak. There's one that I missed to admit. Sorry, Tiffany. Right. So next week, what are we going to do is to discuss a bit detail on SFC, supercritical fluid, subcritical water, and a bit other. Okay, so for green solvent, I think that's all. Okay, and the week after that, we are going to do some practice, which requires you to do some preparation for presentation. Yeah, so next week I'll be giving you some tasks. All right, so I hope that you understand at least some principle in green solvent, and then some basic on green extraction. Okay, so we will do more discussion next week. Okay, so any questions before we end? All right, so if there is no question, see you next week. I will share the slide on the technique. Okay, bye-bye.
Okay,
you.
Prof.
Bye,
Thank you,
doctor.
Doctor.
Bye, doctor.